have an exciting hearing today on NASA's efforts to save the world, literally.
The House Committee on Space, Science, and Technology recently met to discuss NASA's plan to defend the planet from asteroids and near-Earth objects. Chairman Babin began with a dire warning.
While most NEOs are harmless, those exceeding a certain size could cause catastrophic, even extinction-level impacts.
Experts from the space community, including Nicola, the Associate Administrator at NASA, outlined the space agency's past projects and future plans. First with the DART initiative in 2022.
NASA successfully demonstrated one method of the asteroid deflection using the kinetic impact of spacecraft with the Double Asteroid Redirection Test, or DART.
And now with the NEO Surveyor mission, which is a space-based telescope designed to detect asteroids headed to Earth.
The mission will improve NASA's ability to discover and then to define the sizes and the orbits of the NEOs to understand the hazard they actually pose to us here at Earth.
Professor Mainzer of UCLA also testified and showed rocks and materials that have hit the planet during past incidents.
I've actually got 3 meteorites here from UCLA's world-class meteorite collection. This is a piece of Canyon Diablo. This was a fragment of a 50-meter sized asteroid that impacted the desert in Arizona about 50,000 years ago. And it was capable of blowing a mile-wide crater in the ground that is still there today. You can see it's quite heavy, solid iron. This object is called Allende. This is a very famous meteorite that represents the dark material that makes up a significant fraction of the near-Earth object population. And this is important because since it's so optically dark, it's made of carbon-rich material, this is hard to see. It's just dark. So this represents an important fraction of the population that we need to find. And finally, I have a piece here from the meteor that exploded over Chelyabinsk, Russia in 2013. This object was no bigger than the room that we're sitting in today, and yet it was capable of sending about 1,600 people to the hospital, mostly from flying broken glass.
But according to the professor, these aren't the rocks that should concern us.
They are even a little bit larger than the ones that I've shown you here today. It's not just an airburst that knocks out some windows or creates a crater in the ground that is, relatively small. Now we're talking about impacts that can actually wipe out an entire region, lay waste to a country, or devastate the planet.
According to the witnesses, the use of emerging technologies like AI can also be utilized to detect asteroids and near-Earth objects.
How can AI and machine learning be used to enable NEO detection and planetary defense? And what are the potential advantages of using those tools?
So the work that the Minor Planet Center has been doing in this area is to try and use AI techniques to leverage the vast amount of data that we already have on NEOs, asteroids, use that as a training set to help these AI models understand what does an asteroid look like that's harmful versus one that's harmless. And so once one's trained them, you can then use them to try and look at the data that's flowing into us to very rapidly and accurately pick out the NEOs from the data flow that's coming in. And so that's what our current work is doing, and we want to continue that work to build on that so that we can try and most accurately process the NEO surveyor data when that is presented to us.
The biggest hope for the future is the NEO Surveyor mission and the use of infrared technology.
How will the infrared observations from the NEO survey mission, which you lead, how's that going to really improve our ability to model the impacts? Help us understand that.
It'll benefit us in a couple of ways. It'll help us find the objects, including the dark fraction of the population, which we think is sort of roughly 35 to 40% or so of the population. And it will also help us measure the sizes, because we can quickly convert the infrared fluxes into a diameter as soon as we get an orbit from the Minor Planet Center. That actually tells us a lot about how potentially hazardous something is, just because that's such an important component to the impact energy.
As the hearing concluded, committee members expressed bipartisan support and global participation, but concerns remain about the possible top-line budget cuts at NASA.
Dr. Fox, the Trump administration recently released the top-line numbers for the FY26 budget request, and the president is proposing to cut the NASA science budget, as discussed, by nearly in half. In your testimony before the subcommittee last month, you stated that you could not know the impact of a 50% cut because you hadn't seen the budget yet. and I think you've testified earlier today that you haven't seen the detailed budget, although we have, seen a specific. Can you briefly just tell us what the impacts at a top line would be of a 50% cut? I mean, you run the Directorate. At a top line what the impact on the number of missions or other issues would be. Can you just sort of walk us through that at a top level?
Yes. As you note, the skinny budget, we do have our top line number. Earth science is specifically called out, so we do have the Earth science number. We have not seen any details on the missions or any direction on missions other than the Mars Sample Return Program and the Landsat Next, which is joint with USGS. We await the full President's budget so we can see the priorities and the direction on which missions may be supported or not supported. And I will be happy to come back and brief you when we have that information.